Today I am going to uh, do something from Igcse physics, and from this book called David Seng. It's a course book for the physics Igcse students, and the author is David Seng, and this is the third edition. And from this book, from chapter number 1, that is this one, making measurements, I'm going to solve some few questions from the exam style questions. So in today's session, we are going to do that, right? So let us get started. So this is Igcse physics, and chapter number 1, making measurements, from the book that is physics course book by David Seng, third edition, right? So let us get started. Use this table to answer question number 1 and 2. So there's this table given to you, and you can see the table says there are metal, gold, silver and lead, and the density in gram per centimeter cube is given as 19.30, 10.49 and 11.34. Okay, so let us get started. Question number 1. 3 metal cubes have the same volume but are made up of different metals. Each one is lowered into a beaker of water. Use the data in the table to decide which one will cause the biggest rise in the water level. So in this question number 1, he is talking about 3 metal cubes which are made from this metals mentioned over here, gold, silver and lead, along with that density is mentioned. But he has mentioned here that all the 3 cubes, they have the same volume. You see that? They have the same volume. So the biggest rise in the water level when you put those cubes into the beaker containing water, what will be the rise in the level? So biggest rise in the water level will be in which case? So A is gold, B is silver, C is lead and D is all will cause the same rise in water level. So the answer is, according to me, the answer is D. Okay, this one. I'll tell you why. See, he is telling you that the metal cubes, all the 3 metal cubes, okay, they have the same volume. And you know that density is equal to mass upon volume, right? But the rise in the water level, when you put the metal cubes in the beaker containing water, the rise in the water level depends only on one factor. The rise in the water level depends on the volume only. Okay. So more the volume, more will be the rise in the water level in the beaker. Okay. Less the volume, less will be the rise in the water level in the beaker. So everything regarding this rise in the water level will depend upon the volume. And since he is saying that all the 3 metal cubes are having the same volume, therefore the rise in the water level will be same for all the 3 cubes. Okay, and that is why the option will be all will cause the same rise in the water level. That was question number 1. Question number 2. Again, he is telling you 3 metal cubes have the same mass. This time he is telling you that the mass is same. Okay, but are made up of different metals. Each one is lowered into the beaker of water. Use the data in the table to decide which one will cause the biggest rise in the water level. Now again the question is same, but now he is saying that the mass is the same for all the 3 cubes. So now again using the same logic, density is equal to mass upon volume. Okay, so mass is same for all the 3 cubes. So the density and volume are how they are related. They are inversely proportional. So mass is constant. So density and volume are inversely proportional. The meaning of this is the volume will be more for the metal whose density is less. Okay, the volume will be more for the metal whose density is less. Okay, and which one will show the biggest rise in the water level? The one which has the highest volume. Okay. So he has asked you that only, which will cause the biggest rise in the water level. So the biggest rise in the water level will be caused by the metal cube which has the highest volume. And which will have the highest volume? the one which has the least density. So from the table we will check which one has the least density. So gold has 19.30, silver has 10.49 and lead has 11.34. So you can see that silver is having the least density, and that is why silver will have the maximum volume, and that is the reason the highest or the biggest rise in the water level will be in the case of silver. Okay, so P is the answer for question number 2. Right? Question number 3 says that astronauts land on another planet and measure the density of the atmosphere on the planet's surface. They measure the mass of a 500 centimeter cube of conical flask plus a stopper as 457.23 grams to 3 grams. After removing the air from the conical flask, the mass is 456.43 grams. He has given you that 1 meter cube is equal to 1000 liter. What is the best estimate of the density of the air? So he has asked you to find out the density of the air. Okay. And these are the options A, B, C and D. So the best thing is, let us try to find out the density of the air and then we can choose the option. Okay. So density of the air on this particular planet can be measured in this way. Now first we'll see what is the difference in the masses of the conical flask along with the air and conical flask without the air. Okay. So conical mass, the mass of the conical flask along with water is 457.23 grams, and mass of the conical flask without that air is 456.43. Okay, so the difference of this will give you the mass of the air, and that works out to 0.8 gram. Okay, 457.23 minus 456.43 works out to 0.8 grams. So this is the mass of the air. Okay. Now this is in grams, so let me convert it into kilograms. So it will be 0.8 into 10 raised to minus 3 kilogram. Okay, so this is the mass of the air in kg. It's 0.8 into 10 raised to minus 3 kg. Fine. Now this mass of the air was taken in a conical flask of 500 centimeter cube. Okay, so the volume of the air will be 500 centimeter cube. So let us convert this 500 centimeter cube into meter cube. So it will be 500 into 1 centimeter into 1 centimeter into 1 centimeter, and this 1 centimeter can be written as 1 upon 100 meter, this also 1 upon 100 meter, this also 1 upon 100 meter. So this can be written as 500 into, this is 1, 2, 3, 4, 5, 6. So when it goes up, it will be 10 raised to minus 6. So 500 into 10 raised to minus 6 meter cube. This is the volume of the air. So mass of the air you got in kg, 0.8 into 10 raised to minus 3 kg, and the volume of the air you got in meter cube as 500 into 10 raised to minus 6 meter cube. Now density of the air is given by this formula, mass upon volume. So mass I will take 0.8 into 10 raised to minus 3 kg, and volume I am going to take 500 into 10 raised to minus 6, and the unit will be kg per meter cube. Now this 0.8 into 10 raised to minus 3, very nicely I can write it as 8 into 10 raised to minus 4. Okay, and this 500 into 10 raised to minus 6, very nicely I can write it as 5 into 10 raised to minus 4 meter cube. Okay, this is nothing but conversion. Okay, so I hope you must be knowing this, how to convert it into a scientific notation. Okay, so 8 into 10 raised to minus 4 and 5 into 10 raised to minus 4. Now 10 raised to minus 4 will cut from both the numerator and the denominator. You will be left with 8 upon 5, and the unit is kg per meter cube. 8 upon 5 works out to 1.6. So the density of the air will be 1.6 kg per meter cube. Okay, so there were a lot of conversions to be done to arrive at this answer. So the answer is density of the air will be 1.6 kg per meter cube. So the answer will be A, B, C. This will be the answer D. 1.6 into 1.6 kg per meter. Is that clear? That was question number 3. Let us move on to the question number 4. Question number 4 says that the graph shows the mass and the volume of different objects. So on the x-axis, he has shown me the volume. On the y-axis, he has shown me the mass. Okay, and the 4 objects are placed over here. 1, 2, 3, 4. Okay, so these 4 objects. Okay, you will have to see, the question asked is which 2 objects have the same density. So on the graph, this thing is given 1, 2, 3 and 4, these are the objects. You have to say which two objects are having the same density. Now for answering this question, you can take on the x-axis this as x1. Now can you see this is exactly the same distance, so this you can take as 2x1, right? Okay, this is x1, so this will be 2x1. Suppose this you take y1, then this is same distance, so this will be 2y1, right? So now let us try to find out the density of the objects. Okay, now suppose we want to find out the density of object number 2. Okay, so density is given by, in general, the mass upon volume. Now your mass is on the y-axis and volume is on the x-axis. So from the y-axis, for D2, density of the second object, this one. Okay, what will be the mass? Mass will be, you'll have to go on the y-axis. Okay, so it will be 2 times y1 divided by volume. So you come down over here, volume will be 2 times x1. So 2 gets cut and you will get density of this object number 2 will be y1 upon x1. Fine. Okay. Let us try to find out the density of object number 3 also. So D3. Okay. This will again be mass upon volume. So it will be, what will be the mass of this object number 3? So mass will be, from here you go here, it will be y1 divided by the volume of this object number 3 will be x1. Okay. So you are getting density of 3 is equal to y1 upon x1. So can you see this y1 upon x1? This is also y1 upon x1. Therefore density of object number 2 and density of object number 3 are equal. Okay. So here from this the option will be density of 2 and 3. Okay. So A is the correct option. Okay. 1 and 4 will not have the same density, 2 and 4 will not have the same density, 3 and 4 will also not have the same density. And you have to choose any one from the 4 options. So this is the right option. 2 and 3. These are the two objects which will have the same density. So that was some MCQ type of questions from the chapter number 1, that is making measurements. Okay. And these were the questions from the exam style question, right? So hope you like this particular session. Okay, so see you in the next video with some new questions. Okay, till then, bye, take care all of you.